Good morning, all. Yeah. So, good morning, everyone. Yeah. So, we'll continue the class. Guys, yesterday we are discussing about Euler's theory. Okay. So, we derived a formula of Euler's equation for a column which is subjected to, a column which is having an end conditions when the both ends are pinned, isn't it? Yeah. So, today we are going to discuss in brief. So, what will be the Euler's formula for the other end conditions column? Okay. So let me share the screen. Yeah. Guys, is my screen visible?
Yes, sir.
Okay. Yeah. So see this table. So actually I have shared this table to you yesterday. See, these are the end conditions. Okay. So for these end conditions, let us take the first one, which we derived the formula also. When both ends are hinged or pinned. Okay. So where it is rounded or free. So which is the equivalent length or effective length of the column is L. Okay. So then what will be the buckling load? So the buckling load or the Euler's formula which we derived is pi square EI by L square, isn't it? So this is the formula which we derived in the previous class, right? So what will be your effective length? Your L will be equal to the effective length. So by that, the L can be written as effective length of the column. Okay. So by that, these formulas will be equal. Understand? So that means this L can be written as effective length or effective length can be written as L. Okay. So this is what we derive. In the same similar fashion, even you can able to derive formulas for both ends fixed, other end is free, one end is fixed, other end is pinned, and both ends are fixed. Okay, so the formulas which you are going to arrive when you do the derivation is this. Pi square EI by 4L square is the formula which you will get when you derive the Euler's equation for both ends are free. Understand? So one end is fixed and other end is pinned. You will get the formula as 2 pi square EI by L square. When both ends are fixed, you will get the formula as 4 pi square EI by L square. Okay. See, when L is equal to, you don't know. Okay. So you know these values, isn't it? So here, effective length is equal to 2L. Right? Then what will be the value of L? L length అవుతుందమ్మా ఏమవుతుంది L?
Effective length by
Yeah.
2, sir.
One second. So students are joining in between. Yeah. So effective length will be, sorry, L will be effective length by 2, isn't it? Yeah. So in that way, the L can be written. So substitute L as in terms of effective length. So by that, your value will be pi square EI by LE square. And then, isn't it? So substitute L as L effective by 2. Okay. So then you will get this value. Okay. Here also the same. What will be L here? When your L effective is L by root 2, what will be your L? Root 2 into L effective, isn't it? Right? So substitute L as root 2 into L effective, you will get this value. Okay. So your L effective is L by 2. What is your L value? 2 into L effective. So substitute L as 2 into L effective here, you will get again the same value pi square EI by L square. Understand? So this is what I would like to share you, okay, for calculating the buckling load of different end conditions of the column. Understand? Clear? Guys, are you clear? So finally, what will be the Euler's formula? Finally, what is your Euler's formula to calculate the buckling load of the long column? Enti, what will be Euler's formula?
Pi square E.
Just pi square EI by L effective square will be your final formula. In this, which parameter is going to be varied?
L effective.
2 will vary. Okay. So L effective will be based on the end conditions of the column. Understand? So by just substituting your L effective value here, your buckling load of column will be varied based on its end condition. Understand? So this is what I would like to share. And in competitive exams, it is very important. You have to remember all these formulas. Okay. Right? Or else, even though if you won't remember, if you remember these end conditions, substituting your values in terms of L, you can able to achieve this value also. Okay. So, మీరు L effective ni substitute చేయండి 2L గా, you will get this value. Substitute your L effective as L by root 2, you will get this value. Okay. So, substitute your L effective as L by 2, you will get this value. Okay. Understand? So, either way you can get. Okay. So, this is what the buckling load, okay, based on the Euler's condition. Clear? Understand? Ever doubts my Euler's equation lo? Emma, please respond. If you have any doubts, so please respond. Then we can start the new topic. Guys, please respond. Are you clear with the Euler's formula?
Yes, sir.
Yes? Okay. So now let's see this one. What is this? Can anyone? What you are observing here? The first one. So this is a crushing load. So this is a short column. Okay. Which will fail under crushing. So crushing in the sense your load is perpendicular to its cross section. Avuna? Right? The name load antarama. So it is called a direct load. So through the direct load, what you will achieve? Through the direct load, what stress you will get?
Direct stress.
Very good. So this is what a direct stress. Okay. So through the direct load, you will get a direct stress. And short columns will fail under direct stress. Okay. Right. Next, coming to C. Let's talk about C now. Okay. Yeah. So this is what we discussed till now, which is a long column. So long columns will fail under
buckling.
Buckling. It's clearly shown here.
Crippling.
Yeah, buckling or crippling. Buckling will happen here. Crippling will happen here. Okay, right. Understand? So what you understood here, long columns will fail due to what load? Crippling load, crippling or buckling load. Antena? Right? Yes or no? Please answer to my question. Yes or no? This will fail under crippling or buckling load. This will fail under direct load or direct stress. Antena? Right? What is this direct load? Can anyone tell me what is this direct load? Direct load entamma? Direct load ante crushing load annandi. Crushing load is equal to direct stress into cross sectional area. Understand? So this is how you are going to get the direct load PC. PC ante crushing load. Okay. So basically here the column will crush. Why? Because as a short column will undergo crushing. Long column will undergo buckling. how to calculate here crippling load? What is the crippling load formula? Is it correct enough?
Yes,
Right?
sir.
దీన్ని క్రిప్లింగ్ అనొచ్చు లేకపోతే యూలర్స్ ఫార్ములా అందాం. యూలర్ అంటే ఏంటి? క్రిప్లింగ్ ఆర్ బక్లింగ్ లోడే కదా, రైట్? Emma, first please tell me, everyone, have you understood this A and C? A is nothing but direct load or direct stress where your short columns will undergo crushing. C is nothing but long columns which undergoes buckling or crippling. Okay, so that load we calculated with the help of Euler's formula. And then what is this B? What is this middle one? This is called intermediate column. Understand? Intermediate column. What do you mean intermediate column? Intermediate columns ante the columns which won't be short, which won't be long, which will be in between short column and long column. Okay, so the columns which are in between short column to long columns are called intermediate columns. Then what happens to intermediate columns? Intermediate columns will fail under two conditions. Okay, what are two? Intermediate columns will fail under direct load plus buckling load. అర్థమవుతుందా? అంటే intermediate columns will have a crushing and intermediate columns will have even a buckling also. This is what practically possible. Understand? Practical ga jarigedi idanamata. Okay, so practical, there is a possibility of direct load which creates a direct stress. Practically columns will undergo buckling, okay, along with the direct load, so where it will have a buckling stress, okay, so or crippling also. Understand? So this is what practically possible. So how to calculate this? How to calculate this combined load? ఈ combined load ఎలా calculate చేయాలి? How to calculate this combined load where the column is subjected to direct load plus buckling load? How to calculate this combined load? ఈ రెండు యాడ్ చేస్తే combined కదా. Then how to calculate this combined load? This combined load is going to be calculated with the formula called Rankine's formula. Okay na? Understand? Andarku ardhamainda? So this is called a combined load. This combined load is going to be calculated based on the Rankine formula. Through the Rankine formula, we are going to, okay, calculate load PR. So PR is nothing but Rankine load, okay, which is a combination of direct load plus buckling load. Direct load will make column to crush, buckling load makes columns to buckle. Okay, so that combined failure will happens in the intermediate columns. Okay, intermediate columns are the one, ikkada chudandi chala clear ga undi. Intermediate columns are the one which fail due to yielding, which fails due to buckling also. Yielding ante entamma? Direct stress. Okay, yielding is nothing but direct stress or direct load. Okay, so buckling is due to Euler's load, okay, or Euler's condition. Understand? So this is what we have to understand clearly, okay, why we are studying the Rankine formula. ఇప్పటి వరకు మీకు Euler's formula ఎందుకు చదివామో మీకు అర్థమైంది, అవునా? So why we have studied the Euler's formula? To know what is the buckling load of the column, of the long columns which fail under buckling. Antena? Right? So then what is the purpose of studying this Rankine formula? To calculate the combined load where the intermediate columns are subjected to direct stress plus buckling stress. Direct stress plus buckling stress, or buckling load or direct load. Clear? So let's derive what is this Rankine formula. ఈ ర్యాంకైన్ ఫార్ములా ఏంటి అనేది మనం చూద్దాం. ఓకే రైట్ గైస్, ఆర్ యు ఆల్ క్లియర్? మీ అందరికి కాన్సెప్ట్ అర్థమైందా? ప్లీజ్ గైస్, ఐ వాంట్ రెస్పాన్స్ ఫ్రమ్ యూ బికాస్ దీస్ ఆర్ వెరీ వెరీ ఇంపార్టెంట్.
అండర్స్టూడ్ సార్.
నువ్వు ఒక్కడే కాదు, ఐ వాంట్ రెస్పాన్స్ ఫ్రమ్ అదర్స్. ప్లీజ్ రెస్పాండ్ అమ్మా. అందరికి అర్థమైందా? వాట్ ఈస్ దిస్ ర్యాంకైన్ ఫార్ములా అండ్ వై వీఆర్ స్టడీయింగ్ దిస్ ర్యాంకైన్ ఫార్ములా అని?
Yes, sir.
Clear? Girls?
Yes, sir.
Yeah, see, only 1 or 2 are responding. Okay, ma. Yeah, so let's start doing that. Rankine formula. So this is the practically what possibility. Okay, so what happens, you know, the Rankine. So Rankine is a scientist who suggested, okay, an empirical formula for calculating for all types of columns. Any columns ke general ka use chese formula Rankine formula. What do you mean all types of columns? What it mean? What is his meaning of giving the empirical formula for all types of columns?
It is used for long column, short column, and intermediate.
It is used for both short column and long column. Okay, రెండిటికి యూజ్ అవుతుందంట ఈ Rankine formula. Okay, so which is the empirical formula, right? So now let's start doing the derivation. చాలా సింపుల్ గా ఉంటుందమ్మా. Okay, it's not a big derivation also. So the Rankine is suggesting the formula, so which is a combined formula kada. So 1 by PR is equal to 1 by PC plus 1 by PE. What is this? Rankine formula is equal to combination of crushing load plus Euler's load. Okay, so where PR is equal to crippling load by Rankine formula, okay, which is a combination. PC is equal to crushing load by direct stress. Can anyone tell me what is the value of PC? Sigma C into A. Avuna? Which, why? Because it is direct stress. Next, PE. What is this PE? What type of load it is, Amma?
Buckling load.
Buckling load. What is the value of buckling load? Pi square by L square. Right. Now substitute these values over there. Before that, let me write this in very clear manner. Inkokadi clear ga radam. Okay. Right. So 1 by PR is equal to PC PE by PC into PE. PC plus PE by PC into PE. Right. Next, PR is equal to PC into PE by PC plus PE. Right, sure? So finally, this can be written as PC by 1 plus PC by PE. Am I right, sure? See, anta mathematics, right? So now substitute the values of PC in this equation and substitute the value of PE in this equation. Okay. Substituting PC is equal to sigma C into A. PE is equal to pi square EI by LA square. Okay, try to substitute these two values in this. PR is equal to sigma C into A by 1 plus sigma C into A by pi square EI by LE square. Antena? Right? Next. Sigma C into A by the Lella right 1 plus sigma C into A by pi square E. What is I? Can anyone tell me what is I?
Moment of
Moment of inertia.
How can I write moment of inertia in terms of radius of gyration? What is the formula of radius of
I
gyration?
by
Under root I by sir.
I by
under root
I ante
moment of
I
inertia.
and K square A sir.
antena? Right. So let me write I as AK square. AK square by LA square. Okay. Next, this can be written as sigma C into A by 1 plus sigma C into, okay, this A and this A will get cancelled. And then L E square by pi square E K square. Right? And next, how can you write this? Sigma C into A by 1 plus sigma C by pi square E of LE by K whole square. Right, sir? Yes?
Yes, sir.
So finally, this can be written as sigma C into A by 1 plus, let me take this as constant. Okay, this whole parameter, let me take as a constant. Sigma C by pi square into E. Okay, so then I will take it as constant A. Okay, so why? Because it is not variable, it is constant. Why? Because sigma C depends on what? Sigma C depends on what?
Load and area.
Very good. Sigma C depends on load and cross-sectional area. So cross-sectional area and load is same. So by that sigma C is constant. And what is E?
Young's
Young's modulus of material.
It's also a constant. The material constant. Right? So by that sigma C, pi is normal. Right? So pi is 180. So sigma C by pi square into E, I am going to take it as a constant. So what is LE by K whole square? What is the value of lambda? I mean, what is the formula of lambda? Effective length by
Radius of
I
gyration.
mean, radius of gyration. Antena R anna K anna okate, right? So this can be written as A lambda square, right? So finally, what is your Rankine formula? What is your Rankine formula? Sigma C into A by 1 plus small a lambda square. So this is what your Rankine formula, where A is nothing but Rankine's constant. Under. Okay. So what is lambda? Slenderness ratio. A is Rankine constant. What is capital A? Cross-sectional area. What is sigma C? Direct stress. Okay. So with this, we can able to calculate the Rankine load or Rankine formula. Okay. So what is this? PR indicates that PR is indicating the load which is carried by the, I mean, sorry, not the carried, the load which can a intermediate column is supposed to be subjected with direct load plus buckling load. Understand? So this is how the Rankine formula is going to be derived. Okay. So choose column, don't confuse. After this, this one, and then this, and then this. Okay. Finally, this is your Rankine formula.
Sir,
Yeah.
sir, ఇది అన్ని టైప్స్ ఆఫ్ కాలమ్స్ లో యూజ్ చేయొచ్చు అన్నారు కదా sir.
Very good. Yeah. Any type of column అంటే long column, short column combined together, it is more precise for intermediate columns. Okay. ఎందుకు చెప్తున్నాను అంటే in your residential buildings, all columns are not long columns, and you can't find any short column over there. So those columns are basically intermediate columns anamata. Okay, so what it mean ante indaka meeku picture chupichanu. Let me see this. Let me show this. See, you can't find these kind of columns in your buildings. You can't see all